Hey guys, so excuse me, yesterday we talked about constructing a square. So just really quick, I'm going to kind of go back through the steps that we took. And again, there's more than one way to do this, but I'm going to show you guys kind of the quickest way to do it. So the first thing we're going to do is we're going to start off with a line. And most of you remember that in order to do a perpendicular bisector, we just draw a circle with the radius of AB centered at A, and then a circle centered at B with radius AB, and where those two connect, we connect those two intersection points, and that gives us the perpendicular bisector. Now, a square has 4 perpendicular sides, and which means it has 4 90-degree angles, and all of those sides have to be congruent. So if we want one of our corners to be at A and one of our corners to be at B, then we need the other side to be perpendicular at the point of A. So what we're going to do first is we are going to create a circle centered at A with radius of AB. And now, basically what we're going to do is we're saying, okay, this right here is what we're going to do the perpendicular bisector of, because this is the diameter of the circle, and the center of that point is in the exact center of that diameter. So when we do our perpendicular bisector of this yellow segment here, that's where that line is going to go through. So instead of doing the perpendicular bisector of AB, we need to do the perpendicular bisector of a segment that's centered at A. So by creating this circle here, that gives us a segment to do the perpendicular bisector of. So all this first circle is doing is saying, okay, defining what segment we are going to bisect. So now that we have that segment, what we can do is do the perpendicular bisector of that. So I'm going to come up here. I've still got my circle. I'm going to put one circle centered at B, and now instead of the radius being AB, it's going to be this radius right here, and then go back the other way. So now what we've done is we've given our circles, we've given our circles these 2 intersection points, and so then that allows us to do the perpendicular bisector through here. So I'm going to put my 2 points. I'm going to put one here. I'm going to put the other one down here. And then we're going to put our line through those 2 intersection points. And you can see that that goes through A. Now, perpendicular means 90 degrees. And then to be a square, those sides have to be the same length. So when we do that, this length here has to be the same as this side over here. Now, this part right here is the radius of this circle, and we know that that's not the only radius of that circle. We have a radius here, we have a radius here, we also have a radius here, and just because they're not marked doesn't mean that they're not there. There's a radius here, there's a radius here, there's a radius here. So if we want our sides to be perpendicular and the same length, we need to find another radius that is perpendicular at A. So it would be this segment right here. So we're going to put our next point where that circle and that perpendicular bisector intersect. So I'm going to grab my point here, we're going to put another point here, and then I'm going to hide these 2. So all I'm going to do is grab this show hide object. I'm going to hide this circle, and then I'm going to hide these 2 outer circles, and I'm also going to hide these points that we added, so that when I click outside of there, now I just see these little pieces right here. So the very last thing that we need to do is we need to figure out, we have 3 points of our square, we need to figure out somewhere up in here is going to be a 4th point. So I'm going to grab the circle tool again, and I'm going to start a circle centered at B with a radius of AB, because I know that that's the length. So somewhere along this circle here is where that other side needs to go. And again, same thing here, I'm going to start at F, and I'm going to make my radius FA. And so now I can see somewhere along this part right here is going to be a segment that's exactly the same as this one, but I need it to be 90 degrees. So where those 2 circles intersect should be the 4th point of my square. So when I take my polygon tool and I create this polygon, if I were to measure all of those angles, then you could see that that would be 90-degree angles, and all 4 of those sides would be congruent, which means that they are the same length. So the next thing that we want to look at is, I'm going to go back to Desmos now, and we're going to look at trying to circle a square. So what they're doing now is they're giving us some instructions. So I'm going to go to GeoGebra again. What they've given us is they've given us this square, and what they're asking us to do is they've given us the diagonal, and what we want to do is inscribe that square in a circle. So I'm going to go back to this other Desmos here because we talked a little bit about this yesterday. So if you look at the line from A to G, remember that's called the diagonal, and a square has two diagonals. It's just a segment connecting opposite corners of that square. Now if we look at this, what we should know about AG and FB, those two should be the same length, okay? Those two segments should be the same length because in a square, we'll get to this in a later section, but in a square, those three sides are congruent to each other because this side and this side are congruent to this side, and their 90-degree angles are congruent, so they would be congruent by side angle side. So we know that these diagonals are congruent to each other, okay? If I were to take a circle and I were to center it at that point where those diagonals intersect, what you see is a circle that goes through all four vertices of that square. So that square then is inscribed in that circle. And the way that we get that is by finding where those diagonals meet. So if I were to take this show hide tool, right, and let's hide this polygon here. And then let's hide these two circles right here. Okay, so now what you can see is that I have these two, and actually what they are is these are the diameters of the circle. And if we were to measure those angles, you can see that those are going to be 90-degree angles. So what they're actually doing, and then again, let me see if I can get this to work out here. If I were to measure this segment right here, whoops, I want that one. If I were to measure this segment right here, from F to H is 1.47. From B to H is 1.47. So this segment here is congruent to this segment right here. So I'm going to take those two off, and then again, 1.47. 1.47. So all of those, and that should make sense because these are all radiuses of the same circle. So what those diameters are doing to each other is they are bisecting each other. So if I come back up here and, whoops, I want to do this one again. Let me hide this diagonal right here. Okay, if I wanted to find where that square is inscribed, basically all I have to do is create a diameter and then create the perpendicular bisector for that diameter. So that's basically what we're going to be doing here. We know that that circle is going to touch all four of these vertices. What we have to do is find where along this line is the center of that circle. Well, the center of the circle is going to be where these two lines intersect. And so all we have to do, if we follow these instructions down here, construct a circle centered at A with radius of AD. So that's step number one. Centered at A with radius AD. There's our first one. Okay? The second one says construct a circle centered at C with radius CD. So from C, we go to D. Okay? Draw the diagonal AC and write a conjecture, and that should actually be DB. Draw the diagonal BD and write a conjecture about the relationship between the diagonals BD and AC. So if we go back up here and we grab a segment, okay, this is kind of like what we already talked about in that previous section. Right? These two diagonals have to be the same length, and what they're actually doing is they're bisecting each other. So DB is the perpendicular bisector of CA, and CA is the perpendicular bisector of DB. And then label the intersection of the diagonals as point E. So we're going to put a point where those two diagonals are meeting, and then we're going to use that as the center of our circle, and now we have that square inscribed in the circle. All right, so using the conjecture from your previous activity, use straight edge and compass tools. So once again, we're using circles and straight lines, circles, to create a straight-sided figure. So if we click on GeoGebra again, so what they're going to do this time is they're going to give us a circle, and what we have to do is construct a square that is inscribed in a circle. So let's think about this for a minute, okay? If we look back at this one here, remember, if we take away, let's hide some of these things here so it's a little bit more clear for us. I'm going to take away the square, if I can. I don't know if I can do that. Might not let me. And I'm going to take away these two pieces right here. No, I can't take away that square. But I'm going to draw this segment back in. Okay. Now, if I look at these two diagonals of the square are actually diameters of the circle. And we started off with one of those diameters. And then in order to figure out where the center is, we can't just eyeball it. We had to actually do the perpendicular bisector of this segment right here. So the very first thing that we need to do is let's start with a point on that circle. Okay? And then what we're going to do is we are going to create a line. So we're just going to connect those 2 points because in between the lines of that circle, that's the segment. That's our diagonal. Okay, so this right here, this is the diameter of the circle. That's going to be one diagonal of our square. We just have to figure out where's the other one going to go. We know that it's going to go through A, right? We have to figure out where those other 2 corners are, but we can't eyeball it, remember? We have to figure out where that 90 degrees is going to be. So we're going to do this perpendicular bisector again. We're going to start at C, and we're going to go to A, and then we're going to start at D. Sorry, not that. We're going to go start at C, and we're going to go to this point over here, and then we're going to go back. Because remember, we want that bisector to go through A. So this is the segment that we're bisecting. So circle with the radius, circle with the radius. And now we've got this line right here. And now we can see that these 2 lines, they have intersection points on the circle. So they intersect with these circles. So we've got an intersection point here, an intersection point here, here, and here. Now, those are the 4 corners of our square. So if we take the polygon tool and just click on each one of those 4 sections, you can see now this circle right here has a square inscribed in it. This square has all 4 of its vertices touching that circle. So basically, what we've learned, I would like for you guys to go through and do this build a house, so just click on that and follow the instructions there. Basically, any shape that we've used, we can use perpendicular lines, we can use congruent segments, we can use all these intersection points of the circles to create shapes inscribed inside of these circles. So once you get done with this, I would really enjoy it. I would love it if you guys would go through and just practice some of these problems here, okay? If you have any questions, let me know. Have a good weekend.